Hello everyone, welcome to the discussions of the past year questions. This video we shall discuss about the past year paper 2023 October-November paper 12. Okay, let's take a look at the question number 1A. Use standard result from the list of formulae MF19 to find the sum of the series here in terms of n, simplifying your answer. So for this question, consider quite straightforward. We just need to use the formula booklet, MF19, split them to become this one by one. Just like that. Then formula booklet, MF19, you get this one as a 3n plus 1, 2n plus 1 over 6 plus the 3n plus 1 over 2 plus the n. So you can see that the common factor that they have n, so we can take the n out. I think before that, let me just simplify first before I factorize. So this one I get a 2, this one I get a 3n, n plus 1 over 2. This one is the n. So I will take the n over 2 out. So the first part, the first term, I have a 2n squared plus 3n plus 1. The middle term will have a 3n plus 3. This one is a 1. So you expand and simplify, you get this one as a 2n squared plus 6n plus 6n. This one, make a mistake. That's supposed to be a 2 here. So this one's supposed to be a 6. Then you can see that you can factorize them. You can become n squared plus 3n plus 3. Done. That will be the answer for the part A. So now we move on to the part B. They ask you to show that this relationship is true. So to show the relationship is true, just start from the left-hand side. Join together, you get r plus 1 cube minus the r cube divided by the r cube, r plus 1 cube. Combine them together as one fractions. Then we just need to expand them by using the binomial expansion for the numerator part. You get r cube, 3r squared plus 3r plus 1 minus the r cube divided by the r cube, r plus 1 cube. Cancel the r cube, then you get 3r squared plus 3r plus 1 over the r cube, r plus 1 cube. Shown. That is the first part. After that, they want you to use the method of differences to find the series over here. So this one just continue from the information given. So this one just write down the series, 3r squared plus 3r plus 1 over the r cube, r plus 1 cube. Then write them in the form of another relationship at the left hand side. It will be 1 over r cube minus the 1 over r plus 1 cube, like this. So what you need to do now is to substitute the r equal to 1 until n inside. So you can get the first will be 1 over 3 minus the 1 over 2 cube, 1 over 1 power 3, sorry. Then minus the 1 over 2 cube plus the 1 over 2 cube minus the 1 over 3 cube plus the 1 over 3 cube minus the 1 over 4 cube. So you can see that this can be cancelled. Okay. However, we need to show until that the terms until n. Okay. So since we can find the pattern, the rest in the middle, you can ignore it. And then I just show the last two term. The last term, definitely this one must be n cube. This one must be n plus 1 cube. Then this one, before that, it will be n minus 1 cube. This one will be n cube. So you can see that they behave in the pattern that all can be cancelled in this way. So therefore, this one can be written as 1 minus the 1 over n plus 1 cube. Just like that, done. This will be the answer for the sum of the series over here. Then move on. So move on, the part C, we just need to find the sum to the infinity. So what you need to do now is to write down the sum to infinity for the 3r squared plus 3r plus 1 over the r cube, r plus 1 cube is equal to the limit of n going to infinity, the whole result that you have found in the part B. So it will be 1 minus the 1 over n plus 1 cube. So when n approaching to infinity, this will become a 0. So at the end, it will be 1 minus 0, and we will just write it as a 1. Just like this. Done. Okay. Okay, so now we move to the question number 2 right now. Prove by mathematical induction that for all positive integers that this relationship holds. So what you need to do is to show that when n equal to 1, you have a dx of x squared e power x. Just apply the product rule. Keep the left, differentiate the right, plus keep the right, differentiate the left. And if you factorize it out, you will have x squared plus 2x e power x. But we need to show that it will fulfill the right-hand side. So in order to show that it's fulfill the right-hand side, we just follow. It will be the same as the x squared plus the 2 times 1. N is a 1 over here. Plus the 1 multiplied by 1 minus 1. So true for n equal to 1. Then we assume true for n equal to k, which means dk, dxk of x squared e power x will equals to the x squared plus 2kx plus the k multiplied by k minus 1 e to the power of x. So this is what we assume, okay? And we need to show that it will be true for n equal to k plus 1, okay? So the first two steps done already. Now we go for n equal to k plus 1. And n equal to k plus 1. So you have a dk plus 1 dx power k plus 1 of x squared e power x. This is actually the same as a ddx of the result over here. Okay, just copy the result. So this one, it will be x squared plus 2kx plus the k minus 1 e power x. So now we are having keep the left, differentiate the right, plus keep the right, and differentiate the left. Factorize the e power x out, then you have x squared plus the 2k plus 2x plus the k squared plus k. Okay. Over here, we just split them with a proper bracket. so that it will not look so confusing. So we need to show that it will be the same as this. Bring the 2 out, plus the k plus 1, k plus 1 minus 1, multiplied by ex. Okay, space constraint. So I will write my ex over here. Okay, so this will be true for n equal to k plus 1. Then the conclusion, by BMI, the result over here, just copy down the result, d power n, the x power n of x squared e power x is equals to the x squared plus 2nx plus the n minus 1 e power x. Just show that this relationship is true. But we need to make sure that it will not confusing. So just put a bracket with a different kind of shape. Okay, so this one is the n. This is the n. Done. So complete. Okay, now we take a look at question number 3. The matrix M is given by the multiplication of these two matrices over here, where k is a constant and k not equal to 0 and k not equal to 1. Part A, the matrix M represents a sequence of two geometrical transformations. State the type of each transformation and make clear the order in which they are applied. So the order will be starting from the most right-hand side. So this will be the first. This will be the second. So the first one is you just need to refer to the specific matrix over here. So this matrix is representing shear. Okay, so you just mentioned that it's a shear along the y-axis with the y-axis fixed. Okay, sorry. This one is supposed to be a shear with the y-axis fixed, followed by this one. This one is the stretch parallel to the x-axis with a scale factor of k. Okay, so followed by stretch parallel to x-axis with scale factor k. Just like that, done. This will be the answer for the part A. Then now part B. They having a unit square. So unit square means is 1 unit. The square is 1 unit. It's a 0, 1, 1 here. Okay. So unit square, the area will be a 1. It's transformed by M onto the parallelogram OPQR. So after you transform by M, then you will end up at the image of OPQR. Find in terms of K, the parallel area of parallelogram OPQR. That means the area of image and the matrix which transform OPQR onto the unit square. Okay. So what you need to do over here is first of all, you multiply the M, K 0, 0, 1 and 1, 1, 1, 0. You multiply them, you will get K1, 0, 1. Okay. Then the area of OPQR, you need to find the determinant first. Determinant of M is K. So the area of OPQR, which is the area of image, is equal to the modulus of a determinant m multiplied by 1 unit square. Okay, because the unit square is actually the area is 1 unit. So this one multiplied by 1. So this one will be the same as a modulus k. Because we do not know the value of k is positive or negative, we just put modulus k will do. Okay, just like that. Then after that, we want to find the matrix that transform the image onto the object. So in order to find the matrix that transform image to the object, that means actually we're looking for the M inverse. So the M inverse will be 1 over k. These two values swap. This one just put negative. So this will be the M inverse. Done. C. Show that the line through the origin with the gradient 1 minus k minus 1 over k minus 1 is invariant under the transformation in the xy plane represented by M. So actually we need to show that this is an invariant line. So invariant line, that means it will be y. This will be a gradient. Okay. So we let our y is equal to this. Okay. So the transformations of M. So this one, it will be the matrix M just now. The matrix M just now was K101. This is the object. Object is the xy. But because the y is given as this, okay, because the y is given as this, so we just change our y to become 1 over k minus 1 multiplied by x. So we want to show that the line through the origin is invariant. Okay, this is invariant. So to show that it's invariant, that means by right, you need to show that at the end it become x, and then 1 minus k, 1 over k minus 1x. You need to show it like this. Okay, but before that, what we can do is that we need to expand them. So if we expand them, then you will get this as the kx. Okay, kx, only one kx. Then this one is an x plus the 1 over k minus 1x. So over here, you can see that if you combine the second term, the second expression over here, this part, if you combine it together as one term, so you can see that you are going to have k and k minus 1x. Okay. So now you can see that they all can factorize a k out. Then you get this. So this is the object. This whole thing is the image. And you can see that the image is actually the multiple of the object, multiple by k. Okay. So from here, it shows that the image is still in the same line. Okay, which means that this y equals to the 1 over the k minus 1x is an invariant line. Okay, let's show like this will do. So this one shown. Okay, done. That is the answer for the question number 3. Look at question number 4. The cubic equations given as like this: 27x cubed plus 18x squared plus 6x minus 1 equal to 0 has the root alpha, beta, and gamma. So part A, they want you to show that the cubic equation with the root 3 alpha plus 1, 3 beta plus 1, and 3 gamma plus 1 will be given as the following expression. So what you need to do now is actually just need to let the y is equal to the 3x plus 1. Then from here, you can get x equals to the y minus 1 over 3. So from the equations here, 27x cubed plus 18x squared plus the 6x minus 1 equal to 0. Replace all the x, become y minus 1 over 3. Then this one will become y minus 1 over 3 squared. Then this one will be a y minus 1 over 3 minus 1. Okay, so just expand using the binomial expansion. You can see that this is 27. This one is the y cube minus the 3y squared plus the 3y minus 1 over the 27 plus the 18 of the y squared minus the 2y plus 1 over the 9 plus the 2y minus 2 minus 1 equal to 0. Cancel the 27. So you get a 2. Then you get a y cube minus a 3y squared plus 3y minus 1 plus the 2y squared minus a 4y plus 2 plus 2y minus 3 equal to 0. Simplify further, and you will get y cube minus the y squared plus the y and minus the 2 equal to 0 shown. Okay, so this will be the answer for the 4A. Move on. They saying that Sn is equal to the 3 alpha plus 1 power n and 3 beta plus 1 power n and 3 gamma plus 1 power n. Okay, so this is your Sn. So to find S2, actually you just need to take from here, because all the root over here is in the form of alpha plus 1, 3 alpha plus 1, 3 beta plus 1, and 3 gamma plus 1. So when you want to find the S2, so we just take from here. What you can do is just use the formula. It will belongs to the, okay, maybe I copy down the result. Y cube minus y square. Y cube minus a y square plus y minus 2 equal to 0. Yeah. So from here, you just need to take this value, because this one is supposed to be, by right, supposed to be 3 alpha plus 1 plus the 3 beta plus 1 plus the 3 gamma plus 1 power of 2 minus the 2 times of the 3 alpha plus 1, 3 beta plus 1 plus the 3 alpha plus 1, 3 gamma plus 1 plus the 3 beta plus 1 and 3 gamma plus 1. But we in exam, we don't need to write like this because it's kind of complicated over here. So over here, you just need to actually get it from here directly will do. So this one I will erase. This one I will erase. So no need to write in this expression. It's kind of troublesome. Okay, it's kind of troublesome. So what you need to do now is just direct take this is 1 square minus 2 times of the 1. So from here, you will get this as the negative 1. Okay, you will get a negative 1. That is your S2. Then after that, you will be going for the S3. So for the S3, in order to get S3, so first of all, we just need to, from here, from the expression over here, we make it become this. Okay, just make it become y cube equals to the y square minus the y plus 2. So this will be S3 equal to the S2 minus the S1 plus the 2S0. So we already have S2. S2 just now is negative 1. Then S1 is actually the sum of the 3 roots over here. You will get 1 plus the 2 S0. S0 is 3. Okay, S0 is 3. Okay, then just press the calculator. You will get this one as a 6 minus 2. You get a 4. That will be the answer for the B. Move on. Question C. S negative 1 and S negative 2. So in order to get S negative 1 and S negative 2, is actually still following the same relationship over here, S negative 1 and S negative 2. So what I will do is, for me, usually I will write down the original one. I will divide everyone by y cube. Then I get 1 minus a 1 over y plus 1 over y squared minus a 2 over y cube. Then I will rearrange it to become 2 1 over y cube minus the 1 over y squared plus the 1 over y and minus 1 equal to 0. Then I divide by 2 again. If I divide by 2, then I will get this. Okay, so now all the root in these expressions, all the root will be in 1 over 3 alpha plus 1, 1 over 3 beta plus 1, and 1 over 3 gamma plus 1. Okay, so all the root will be in this form if I do it like this way. So over here, to find s negative 1, actually just take it from here. S negative 1 is actually this, but there's a negative in front, so it will be a positive half. Then s negative 2 is actually the half, you square it, minus the 2 times of this value. Okay, so you get a 1 over 4 minus 1, you get negative 3 over 4. That will be the answer for the question number, this is question number 4. Okay, so done. So this one will be the answer for the question C. Okay, so now we continue. Now we move on to the question number 5. Number 5 is the vector. The plane pi 1 has the equations given as such. This is the vector form. Then if we want to have a Cartesian form of the equation of plane pi 1. So in order to do that, just take the directional vector, do the cross product. Take these two directional vector. This is a 1, negative 2, and negative 3. This is a 3, 0, negative 1, 3, 0, negative 1. So over here, just do the cross product. You will get 2i. This one you will get minus the 8j. Then plus the 6k. So this one can be written as, if you factorize the 2 out, you get a 1, negative 4, and 3. So my n normal vector will be 1, negative 4, 3. Just take the simplified one. Okay. Then the pi 1, the equations of plane for the pi 1. So usually I will just write 4 brackets like this over here. This is the normal. This is the normal. This is the xyz. This will be the fixed point. The fixed point will be here. 1, negative 1, negative 2. Expand. You get a 1 plus 4 minus 6. So you get x minus a 4y plus 3z equal to the negative 1. Done for the part A. Part B. They are telling you that we have a line L does not lie on the L pi 1, and the line L has the equation like this. So L1 has the equation like this. Negative 3, 0, 1 plus the t of 1, 1, 1. Okay, how do you know that the L is parallel? So if the line is parallel, okay, because the question already mentioned it does not lie on the pi 1 already. So what I need to do, you just need to show that it's parallel. So parallel, the things over here is that the n over here and the directional vector over here, they must be 90 degree. Okay, so what you need to do is to show that the normal vector is a 1, negative 4, 3, dot product with the directional vector, see whether you will get 0. You will get 1 minus 4 plus 3, you will get 0. Okay, so therefore L is parallel. 2 by 1. Just like that. That will be the answer for the number 5B. Move on. C. They want to find the distance between the L and the pi 1. Between the L and the pi 1. So like a diagram that I drawn already, over here you can see that this will be the distance. We're looking for the distance since they are parallel. So there will be a shortest distance between the line and the pi 1. So over here, if you can memorize the formula, you just apply the formula directly. If you cannot memorize the formula, then we will try to figure out how to build the formula ourselves. So imagine that we have a P like this. This P just now is a 1, 1, 1. And we have an N like this. This N just now was a 1, negative 4, 3. And you can see that, oh, sorry. We have a line L. Okay, so you can see that the line L, just now, let me copy down the L. The line L is negative 301. Negative 301 plus the T of 111. So that means this line L has a point called negative 301. And for the plane by 1, the plane by 1 just now, plane by 1 consists of 1, negative 1, negative 2. So there will be a 1, negative 1, negative 2 over here. So what you need to do is to combine them like this. Okay. So what I need to do now, no need to write like this. No need to provide a diagram as well if you don't want to. Just say that we just let our OA equal to 1, negative 1, negative 2. Our OB is equals to the negative 301, and we want to find AB. So to find AB, just take the B minus A, negative 4, 1, and then 3. Negative 4, 1, and then 3. Okay. So the formula, the shorter distance, the D. So what I need to do, actually, maybe the diagram didn't stated it very clear. Okay, let me erase it. So you have a line. Then just now you have a point called A. You have a point called B. So you have found AB. I will call this a theta. So we are looking for the distance over here. This distance is the D. So D is actually magnitude AB cos theta according to the diagram. Okay. This whole thing over here is D. Okay. So if you look at the diagram, you have a, you have a B, you have a theta. So AB is here. You are looking for the D. This is 90 degree. So the D is actually more magnitude of the AB cos theta. So we can actually convert it to become AB divided by, AB multiplied by N cos theta divided by the magnitude N. So this will be the same as the magnitude of AB, the dot product between the vector AB and N divided by the magnitude N. Okay, so this is the formula. So actually, you no need to show this. Actually, no need to show this. Just direct give me the formula will do. Okay, just direct give me the formula will do. So over here, we just have the AB, negative 413 dot the N. N is 1, negative 4, 3 divided by the magnitude of the N, 1 plus 16 plus 9. So this one, just use your calculator. You will get the answer as the 1 over sub 26, or you can write it as a sub 26 over 26. That will be the answer for the distance between L and pi 1. Done. Then D, you have a pi 2. So pi 2 is given as a 3x plus the 3y plus the 2z. equal to 1. So from here, you can find your N2. Your N2 is 3, 3, 2. Your pi 1 just now was x minus the 4y plus the 3z equal to -1. Then this will be your N1. Okay, so this is what we are having. Then the question want to find the line of intersections between the two planes. So what you need to do, just need to take the cross product between the N1 and N2. So N1 and N2, you do the cross product. Either you take N1 cross N2 or you take the N2 cross N1. Then this one, you will get a 9 plus 8, you get a 17i. You get 9 minus 2. 9 minus 2 is 7, negative 7j. Then this one is the negative 12 minus 3, negative 15k. Okay, so this will be the directional vector of the line. Okay. Now, what you need to do is we let our z equal to 0. So from the pi 2, I will get 3x plus 3y equal to 1. You have x plus y equal to 1 over 3. I call this equation number 1. Then for the pi 1, equation pi 1. For the equation pi 1, you will have x minus a 4y equal to -1. This one is the second equation. So take the first equation minus the second equation, you get 5y is equals to the 4 over 3. Then the y is equals to the 4 over 15. If the y is equal to 4 over 15 from the equation 1, the x will be 1 over 3 minus y. So that means it will be 1 over 3 minus a 4 over 15. You're supposed to get 1 over 15. Okay, that is your x. So therefore, the equations of line, the vector equations of line, let's write down the vector equations of line is r equal to the coordinate. Okay, so this coordinate is x, y, z. Your x is a 1 over 15. Your y is a 4 over 15. Your z is a 0 plus the lambda of a directional vector 17, -7, and -15. Done. That will be the answer for the number 5D. This will be the answer for the number 5D. Okay. Okay, now we take a look at the equation number 6. The curve C has the polar equations r equal to the e power negative theta minus the e power negative half pi, where the theta is from 0 to pi over 2. A. Sketch C and state in exact form the greater distance of a point C from the pole. So what you need to do is to sketch the graph, to sketch a curve. Over here, we need to draw a table. So this theta, this is the R. So from 0 to pi over 2, you can actually try to show some special value over here. You can just use pi over 6 and then pi over 4, pi over 3. Then the last one is a pi over 2. Okay, so it depends on how many points you want. So over here, of course, if you want to have a better result or the better graph, so you can have all the 5 of them here. But if you don't want, you can just use 0, pi over 4 to pi over 2 will do. Okay. But over here, in order to get a better result, so I will have these 5 value. So I just use your calculator, calculate them. Since I plot the point, over here, I think just 1 decimal or 2 decimal should be enough. So over here, I get 0.38. 0.25, 0.14, and this is 0. So from here, in order to plot the point, this one is polar curve. So theta equal to 0. This one is theta equal to pi over 2. This one is a 45 degree. Then 30 degrees over here. And 60 degrees somewhere. So must use a proper scale. So over here, I use a different color to show you the point. So this one is at the pi over 2, you get a 0. When the theta equal to 0, you get 0.79. Then pi over 6, you get 3.8 somewhere here. Almost half of this. Okay. So the distance will be cut into half. So then this one will become smaller, 0.25. Then 0.14. So at the end, your graph will be like this. Okay, your graph will be like this. Okay, so this will be the graph of the polar curve C. Then the further distance from the graph, of course, this will be the further distance, but they want exact form. So the further distance will be, we call the Rmax. Okay, we can call it Rmax. Is equal to the e to the power of negative 0 minus the e to the power of negative pi over 2. You can write it as a 1 minus the e power of negative pi over 2. Done. That will be the answer for the part A. Then part B, find the exact value of the area of the region bounded by C and the initial line. So bounded by C and the initial line, actually we are referring to the area here. Okay, so this is the area that we are referring to. What you need to do now, just formula of the integrations. So the area will be half integrate from 0 to pi over 2 of r square d theta. So your r square is going to be e to the power of negative theta minus the e power of negative pi over 2 square d theta. And if you expand them, this one have to be careful. Negative 2 theta minus the e to the power of negative theta plus pi over 2 plus the e power of negative pi d theta. Okay, so this is what the expansion is. Now just integrate them one by one. You get negative half e power negative 2 theta, and you get a positive 2 e power of negative theta plus pi over 2 plus the e power negative theta and negative pi and then theta 0 to pi over 2. Just have to be very careful because this kind of expression is quite confusing. So this one, it will be e power of negative pi plus the 2e power of negative pi plus the pi over 2 of e power negative pi minus minus the negative half plus 2e power of negative pi over 2 plus a 0. Okay. Then expand. You can see that actually these two are the same. So it will be 3 over 4 e power negative pi plus the pi over 4 of e power negative pi plus a half, no, not a half, plus a 1 over 4 plus the half e power of negative pi over 2. Wait, not half, it's a 1. Okay, minus, there's a minus here. So I forgot to multiply. So you see, quite confusing. If you have to be very careful. If you're careless, then your answer will be wrong. So this one will be minus the e to the power of negative pi over 2. Just like that. Done. Unit square. That will be the answer for the B. Move on. They ask you to show that the point C furthest from the initial line equal to this equation. So what you need to do now is, first of all, you are having r equal to the e power negative theta. This is what the question gave you. In order to find the further distance of the initial line, that means actually we want to look for the y max. To look for the y max, that means you must have a dy dx equal to 0. Okay, but over here, this one is only r and theta. So we will multiply by sine theta first. So you get r sine theta equals to the e power of negative theta minus e power of negative pi over 2 sine theta. Then you get this as a y. So in order to get the maximum distance from the initial line, just have a dy d theta equal to 0. You don't have to make it become dy dx equal to theta. So I just want to have a dy d theta equal to 0. So dy d theta is you keep the left, differentiate the right, plus you keep the right, and you differentiate the left. And your dy d theta equal to 0, that will give you e to the power of negative cos theta minus a sine theta e to the power of negative theta equal to 0. And you can see that the questions have tangent theta. Okay, so what you need to do is we're going to divide the equation over here by cos divided by e power negative theta and cos theta. So if I divide by e power negative theta and cos theta, then I will get this. This one I will get tangent theta. Split them. You get a 1 minus e power of theta minus a pi over 2 minus a tangent theta equal to 0. Okay, so shown. Okay, now we want to verify that there's a root between 0.56 and 0.57. Now we let the f theta equal to 1 minus a e power theta minus a pi over 2 minus a tangent theta. Then change your calculator in the radian mode. Press a calculator for f 0.56 and 0.57. So this one, if you press a calculator for f 0.56, remember change your calculator into radian mode. You get positive. This one you get negative. Okay, so because there's a changes of sign, just mention that because of there is changes of sign between 0.56 and 0.57. Therefore, the equations has a root between the two values stated, between 0.56 and 0.57. Just like that. That will be the answer for the questions 6C. Okay, so move on, it will be question 7. Okay, move on is question 7. Now we take a look at question number 7. The curve C has the equation y equal to fx, where fx equals to the x squared over the x plus 1. Find the equations of the asymptotes of C. So for these questions, we have vertical asymptote, just to let your denominator equal to 0, and then you get x equal to -1. And for the oblique asymptote, or the slanted, or the slant of asymptote, over here we need to do the, you can use long division to reduce them, or you can just straight away, usually I'll do like this, because this one is the improper fractions. So for the x squared over the x plus 1, I will make it become x plus 1 minus x. Then I continue to do so. Minus x plus 1 plus 1. So from here, I can factorize it like this out. Then I can get this as x minus 1 plus the 1 over x plus 1. That is my fx. So from here, I will get my oblique asymptote, which is the y is equal to x minus 1. Done. So I have two asymptotes here. One is a vertical asymptote, one is an oblique asymptote. Then part B, they want you to find the coordinate of the stationary point. So in order to find the coordinate of the stationary point, you need to do the differentiations. So for this question, the differentiations usually, of course, usually the differentiation we differentiate from here. But since I have reduced it to become this form, I reduce the fx to become this form, then it's better for me to differentiate it over here. That will be faster. So for me, I will differentiate from here directly, faster. So if you differentiate from the fx, you get 1 minus the 1 over the x plus 1 square. Then the f prime x equal to 0. That will give you 1 over the x plus 1 square equal to 1. Then you have x plus 1 equal to plus minus 1. And you have x equals to 0 and x equal to -2. Okay. Then when the x is 0, your f0 or your y will be a 0. When your x is a -2, your f -2 will be a -2 square. -2 plus 1, you get a -4. So therefore, your stationary point are 0, 0, and 2, -4. Okay, so this is the stationary point. Then for the for the C, you need to sketch a graph. So in order to sketch a graph, I draw with the freehand, so my graph may not look so nice. However, you just need to understand, you just use, when you draw it on a hard copy, you can use the ruler to draw it better with the proper scale. Okay. Then I have a -1. Okay, so my oblique asymptote, this is my oblique asymptote. This is my vertical asymptote. So the graph will pass through 0, 0, and the graph will pass through -2 and -4. -2 somewhere here. So from here, the graph, obviously, this is going to be like that. It's going to be like this. Oh. The features of the asymptote need to be shown or seen clearly. So let me just extend over here like this, so that I will draw my graph. Okay. So this will be the graph for the C. Done. Then D. Find the coordinates of the stationary point on the curve with equations y equal to the 1 over fx. Okay, so in order to get stationary point, so just now in our O function or the O graph, your x equal to 0, then your fx equal to 0. Your x is a -2, then your fx is a -4. Then if you put a reciprocal, this will going to be infinity. Then if you put reciprocal, this one is going to be -1 over 4. So for this case, you only have one stationary point. This is previously, this one was minimum, then this is a maximum. So now after previously this is a maximum, now this one will become minimum. Okay, so what you need to do now, we just need to, okay, we need to differentiate. Okay, so not suitable to use a table like this to represent. So we need to show some working over here. We just let our y equal to the fx power of -1. When you write a dy dx, it will be a negative fx power of -2 f prime. And in order to get the dy dx equal to 0, then your f prime x must equal to 0. So just now we know that f prime x equal to 0 means we have x equal to 0 and x equal to -2. But the f0 equal to 0, so therefore this one is ignored. But the f -2 is f -2 is -4. So therefore your stationary point, okay, your stationary point will be a -2 and -1 over 4. This will be your stationary point. However, this question is only 2 marks, so maybe there's no need for you to show so detailed. But this is my suggestions of the working over here for you to refer. Now we go to the E. Sketch the graph with the y equal to fx, y equal to 1 over fx, and then after that, we want to find the set of values that fulfill 1 over fx greater than the fx. So over here, we want to sketch a graph of 1 over fx. It's actually based on the original graph. Your original graph is like this. So over here, your 0, the 0 over here is going to become, the 0 over here is going to become asymptote. Okay. Then the asymptote over here is going to become a 0. Okay. Then this -4 is going to become -1 over 4. Okay, it's going to become -1 over 4. Then the graph actually the graph is going to be like that. Okay, let me just separate it. So the graph is actually going to become like this. This is the 0 and go up like this. And this one, it will go down over here like this. Okay. So the graph for the E, it will be like this. Okay. But however, the questions didn't require us to draw the original graph and the modified graph together. So what you need to do now is just to draw it like this. Okay. So I think I will use this color. So just to show that the 0 is the vertical asymptote now. Then this is a -2. This is a -1 over 4. So the graph will become this. Then it will be like this. So this is the x, this is the y. Okay. So now for the last part is they want 1 over fx greater than fx. So actually we let them equal first. So you have a fx squared equal to 1. Then you have fx equal to plus minus 1. So from here you have fx equal to 1, which means x squared over the x plus 2 of x plus 1 equal to 1. Then you have x squared minus x minus 1 equal to 0. So from here, you will get the answer for the x in terms of your answer for the x will be the exact form. Because they want exact form, the question mentioned they want exact form. So your answer for this x must be 1 plus minus of square root 5 over 2. Then for the fx equal to negative 1, it will be x squared over the x plus 1 is equal to negative 1. Then you have x squared plus x plus 1 equal to 0. Then you will get, for this case, your b squared minus the 4ac is negative. So this one is no real solution. Okay, this one you have no real solution. Okay. Then our answer will only be x equal to 1 plus 35 over 2 and x equals to the 1 minus 35 over 2. If you compare to the graph, like just now, okay, if you have a graph together over here, you can see that this graph actually have two intersections only. That means one of these must be 1 plus 35 over 2. Another one will be 1 minus 35 over 2. And you are looking for 1 over fx is less than or greater than the fx. Means you want the blue graph to be higher than the black graph. So the part that the blue graph that is higher than the black graph, it will be here. It will be this part only. Okay. And also this part. Okay. So from here, you can see that your answer is x less than negative 1, and the x is between the two roots just now. So from the graph, you have the x negative 1 and the x between 1 plus 35 over 2 and 1 minus 35 over 2. That will be the answer of the set of the value that fulfill the equations, that fulfill the inequality. Okay, just like that. Done. So that will be the last questions over here, and I'll stop the video here.